All right, welcome to 7.3 radicals. We're going to start radicals here. Radicals is anytime you see this symbol, that is a radical. The different parts of the radical are, we have the A, that's usually coefficient. That's typically, usually it's a number, but it could be a variable also. The I, where that is, that's going to be your index. So a lot of times I'll say like it's a square root. We don't usually write the 2 there, but that is the square root. In any other thing else, cube root. So you're looking at the index to tell what kind of root it is. So it's a 4th root. And then on the inside, we call this, underneath the radical, the radicand. A lot of times people will just say what's under the radical. In order to simplify radicals, you must be able to break down the radicand into prime numbers. And I'll show you what I mean there with this. So as a product of the prime numbers. So for 24, you're going to think, what 2 numbers multiply to 24? It does not matter which 2 you choose, as long as it multiplies to 24. So I'm going to choose I'm actually going to go, as long as the number ends in an even number, I'm going to always divide by 2. So 12 times 2, 12 ends in a 2, so that's going to be 6 and 2, 3 and 2. So 24 is 2 times 2 times 2 times 3. 220 ends in a 0, so that's an even number, so that's 110 and 2. 110 ends in an even number, so that's 55 and 2. 55 doesn't end in an even number, but ends in a 5, so that is 11 and 5. So the prime numbers to get to 220 are 2 times 2 times 5 times 11. All right, so this is, we need to be able to do that today. Oh yeah, and by the way, these are called factor trees. Those are called factor trees. All right, so let's get these steps down. So step number 1 is you're going to have to factor the radicand. The number under the radical. Step 2 is we are going to use the index to determine how to group the factors. So step 3 is, for each group, one factor is going to leave the radicand. And I'll explain this in a bit. And the last step is to multiply the outsides. Multiply the outside factors and together, and multiply the inside factors together. So outside times outside, inside times inside. Inside or under the maybe go under. the radicand together. So, all right, so step one, I'm going to try to color code this so we can keep it straight. So step one on number 3, we're going to break down 24. So again, it ends in a 4, so that's an even number, so I'll just do 12 and 2. 12 is ends in an even number, so 6 and 2. 6 is 3 and 2. And I'll write it out horizontally. 2 times 2 times 2 times 3. So now step number 2 is to use the index. So this is a square root. Square root, so we're going to look for pairs. Groups of 2. Well, you can only make one group of 2 out of our factors. So that's going to come out in front. So that's going to come out. Will only one come out. Let me do that in purple. So this is, well, from there, only one group of 2's come out. Then what's underneath, we're gonna leave, we have a 2 times 3, that's gonna stay. They don't have they don't have pairs, so that's gonna stay underneath. It's 2 times 3. And now we're gonna multiply the outsides. There's nothing to multiply on the outside, so that 2 stays there. So it's gonna be 2, and then on the inside, we have 2 times 3 is 6. Here's your final answer. It is simplified because the square root of 24, you see underneath the square root, it's a smaller number. So it is simplified. 220, break that down. Square root of 220, we have 110 and 2. 110 is 55 and 2. 5 and 11. Those are your prime numbers. Prime numbers just mean anything, or the only thing you can multiply to get to that number is 1 in itself. So we have 2, 2, 5, and 11. It's a square root, so for each, so we're looking at the index is a square root, so we're thinking 2, and we have a pair. We do have one pair that we can make out, so that's 2, and then underneath the square root, so this 2 should be in purple. And then it's times, there's nothing else on the outside, no other groupings, so that 5 times 11 will stay underneath. Now we're going to multiply the insides and outsides. So outsides, there's just 2. The insides, 5 times 11 is 55. Uh-oh. Didn't know I had these done. Erase. All right, let's take a look at number 7. Break that down. We have 96, ends in an even number, so that's 48 and 2. 48 is 24 and 2. 24 is 12 and 2. 12 is 6 and 2. 3 and 2. All right, let's write this out horizontally. So we have 1, 2, 3, 4, 5 2's. And then times 3. It is the radicand, or the index is 2, so it's a square root, so we're looking for pairs. So every pair comes out at 1 of whatever the pair is. And we always multiply. And 2 times 3 does not have a pair, so that's going to stay underneath the radical. And we do 2 times 2 on the outside is 4. 2 times 3 on the inside is 6. So the square root of 96 is equivalent, is simplified at 4 squared is 6. And number 8, we have 135 is, let's break that down, as 27 and 5. 27 is 9 and 3, and 3 and 3. I'm write it out horizontally so I can visually see this. 3 times 3 times 5. It is a square root again, so we're only looking for pairs. We can only make out the one pair. So 3 times the square root of 3 times 5. Stays underneath. Outside, there's nothing to multiply together. Inside, we have 3 times 5 is 15. There's our final answer. All right, hopefully this made sense. If it did not, please ask questions in class.